Hello and welcome to another video in the Administration of Operating Systems course. Today I will be going through slides for Lecture 2, the Linux file system. This is not a full-fledged lecture, I will only be highlighting some of the more important aspects of this topic. Therefore, it is important that you pause this video often and take your time to understand the concepts I'm talking about. Preferably, you will also apply a lot of this information on your own, experimenting with the Ubuntu virtual machine you should have installed by now. In general, a file system is a set of data structure used to organize information. On one hand, this information is stored in some particular way on some kind of device, for example a disk, and the organization there depends on the technology that's used to manufacture this device. On the other hand, you have the high-level view that you would like to present to your applications and your user. In general, you would like this view to be hierarchical. You can think of it as some kind of family tree where you have some ancestors and some descendants. And this is a very nice structure because it allows you to have a lot of information organized in a pretty nice way. It's very natural for humans to look at things this way. So a file system hierarchy can look very similarly. You have some files at the ends of those paths, and you have some directories at the branching points. There are different types of file systems that they have their own names. So NTFS is a default file system for Microsoft Windows operating systems. ext 2, 3, and 4 are different versions of the most common Linux file system. In Linux file systems, a directory is just a special type of the file. It doesn't have to be like this. Some other file systems are organized differently, but in this particular case, a directory is just a file which contains entries for all other files, as well as subdirectories. And each such entry consists of the file name and a number called the inode. And inode is used as a pointer to the physical location of data on the device. We will not go into too much detail about how it's actually organized in this lecture. Hopefully we'll have time to look at it a bit more deeply in the future. But for now, this is enough information for you. And each directory, even if it's so-called empty, contains at least two special names. It contains a single dot, which is a pointer to the directory itself, and it contains the double dot, which is a pointer to the parent directory. And actually turns out that this is enough to represent the whole structure. You don't need any additional information about links. And from application and user point of view, each file and each directory has a name. This is the most important thing. You call it file name or directory name. And the constraints on what is allowed as a file name depend on a particular file system type. The interesting thing is that at least in Linux, you can have several different file system types within a single file system. So you can have part of the tree being ext2 and another part of the tree being, for example, NTFS. And that means that some of the file names that are legal in one part of the tree would be illegal in the other one. And also within a given directory, names should be unique because names are the only way you have to access the data. But typically, it's not really the file systems that enforce it. It's only the operating system that enforces it. When you create a file, it first checks that there is no file with the same name. And if there isn't, then only then it allows you to create a file. So if you get low-level access to the device, you can actually fool file systems very often and create several files with the same name. And then depending on the details, this can be more or less confusing to the operating system. But it, for example, can be a pretty interesting way of hiding information because it will be really hard to access this information unless you know it's there. As far as file names go, you can typically use most printable characters, but there are some which are safer than others. So letters, numbers, underscore, period, and comma are always safe to use. Some of the characters have special meaning, for example, space, star, question mark. So if you use those within the file names, then they will be interpreted by the shell as they have special meaning to the shell. So if you want to use them as part of the file name, you have to quote them either with quotation marks or with backslash character. So if you have a single file called my file and you want to print it, that's how the command would look like, or you could use this one instead. File names in Linux are case sensitive, and modern Linux file systems allow you to have file names of 255 character length. That's not always the case. Another important concept is the path name, and path is a series of names that identify a path along file system branches from one file to another. So a starting point is always directory. There is no point in starting a path at a file because you can never go any deeper. And it's important that in Linux, path components are separated by slash, not by backslash, as you may be accustomed to from Windows. And the reason why path name is important is because it can be used to uniquely identify a particular file or directory. If you know a path name, you know to which file or directory it points, at least assuming that you know the starting point. It's also possible that the path name does not lead anywhere. If you, for example, remove the target, then a path name which used to be valid will be now invalid. That can obviously happen. And it's also important to know that in Linux, there can be several path names that refer to the same physical file, and those are called links. So you can have the same information being accessible from different points in the file system hierarchy. Again, we will come back to this idea. Typically, a file name also contains something called extension, which is just the part of the file name after the last dot. And by convention, extensions help describe the contents of the file. So you could have a program written in C programming language, C++ programming language, a binary which was compiled, and so on. And the conventional file name extensions can be used to see it. Or you could have a memo as a PDF file or PostScript file, and you would distinguish them by the extension. It's also very common, especially in Windows, that you use extension to deduce the default action that should be performed of the file if you double click it, for example. This convention has been to some degree adapted into Linux, but it's not as common. So for example, in a lot of labs that you will be doing, the default shell like bash does not use extension to figure out what to do with files. Although you can, for example, use extensions to guide things like file name completion. Again, this is a bit more too complicated for this course, but if this is something you are interested in, you can definitely find information about it on the internet. The important thing about Linux file system is that it's rooted in a single point. So there is no concept of drive letters as in Windows. There is always a single file system root, which is the shortest possible path, the single slash. And all the physical drives are within the same tree, all the hard drives, all removable media, network drives, and so on. And that makes it really easy to define parents and children. Basically, all the directories that are closer to the root are parents, those that are farther away are children. And as I mentioned, there is this concept of links, which actually means that Linux file system is not necessarily a tree. A Windows file system is always a tree, but in Linux you can have a file system which is not a tree. You can have cycles in it. And well, depending how you look at it, it allows you to do a number of interesting things, but it can also be a problem in some cases. There is also a concept called hidden files, as you can see. Actually, I was just joking. Hidden files are files whose file name begins with a period. And this is a convention that most tools, for example ls, which lists files, will not display such files unless specifically asked to. In file systems like NTFS or FAT, hidden is a file attribute. In Linux, it's just a name of the file that defines this. And you have already seen some of the hidden directories. The period and double period, those are hidden entries. They appear in every directory, as we mentioned. And those files can be displayed when you specifically ask for it. For example, using ls-a command will display files like this, while regular ls will not. Here is an example of how it works. And now, if you haven't paused the video ever before, now would definitely be a good place to pause it. Try this command and this command in your virtual machine. See the difference, and hopefully it will make it a lot easier to understand what happens.